Hey, fellow space explorers, and welcome back to the Nerdwork Nexus. So get this. We can now talk about the weather on exoplanets.
Not just like what their atmosphere is like,
Right.
but actual daily weather changes
Yeah.
on planets hundreds or even thousands of light years away.
It's incredible.
It seems like science fiction, doesn't it?
It really does.
But thanks to the Kepler Space Telescope and its incredible data, we're starting to unravel the mysteries of weather patterns
Yeah.
on these distant worlds.
Okay, so for our listeners who maybe haven't been following every exoplanet discovery,
Sure.
remind us what makes these planets so special and how we even find them
Yeah.
in the first place.
Sure thing. Exoplanets, as the name suggests, are planets outside of our solar system.
Okay.
They orbit other stars, and
Really?
we've been discovering them in droves. One of the main ways we do this is through something called the transit method.
Ah, that rings a bell.
Yeah.
But refresh my memory.
So imagine you're watching a car's headlights in the distance, and a tiny gnat flies right in front of one of them.
Okay.
You'd notice a slight dimming of the light, even if you couldn't see the gnat itself.
So it's the same principle with a planet passing in front of its star. We see the star's light dim even though we can't directly see the planet.
Exactly. And by analyzing that dip in light, we can not only confirm the existence of the planet, but also glean information about its size and orbit.
Oh, wow.
But what's really exciting is that recent advancements allow us to use a similar technique to study the planet's atmosphere and weather.
Hold on. How do we go from a dimming star to knowing if it's a cloudy day on some planet light years away?
It's all about observing the changes in light as the planet orbits its star. This is where phase variations come in.
Okay.
You see, just like our moon goes through phases, exoplanets also show different faces to us as they orbit their star.
Oh, that's interesting.
Yeah,
So by studying how the light changes, we can figure out what's happening in its atmosphere.
precisely. We can detect things like temperature variations, cloud formations, and even the composition of the atmosphere.
That is amazing.
Yeah.
So what kinds of planets are we talking about here? Is this like Tatooine level forecasting or what?
Well, not quite Tatooine yet.
Right.
The majority of exoplanets where we can study weather are called hot Jupiters.
Okay.
They're gas giants like Jupiter, but they orbit ridiculously close to their stars.
Oh.
So close that their surface temperatures can reach thousands of degrees.
Thousands of degrees.
Yeah, we're talking hotter than some stars.
Whoa. Forget a sunburn. These planets are basically getting flash fried.
Yeah.
That must make for some pretty wild weather.
Think about it. One side of these planets is perpetually facing the star in constant daylight,
Right?
while the other side is eternally dark.
Yeah.
We call this tidal locking,
Yeah.
and it has a massive impact on the weather.
So basically it's like having one giant, never-ending heat wave on one side and a cosmic ice age on the other.
Pretty much. This extreme temperature difference creates powerful winds that try to redistribute the heat,
Yeah.
leading to some truly fascinating atmospheric circulation patterns.
Okay, so we have scorching hot gas giants locked in a permanent day-night split
Right.
with crazy winds whipping around. What did this particular study actually find out about their weather?
They focused on 6 hot Jupiters
Okay.
and used these phase variations to actually track daily weather changes. 4 of these planets showed signs of what you might call cloudy mornings.
Cloudy mornings.
Yeah.
Are we talking about literal water vapor clouds like we have here on Earth?
Not necessarily. Remember, these planets are incredibly hot.
Yeah.
We're talking clouds made of things like silicates or even iron.
Iron clouds. That sounds heavy.
Mm.
How can they even tell what the clouds are made of from so far away?
It's all about the light. By analyzing the specific wavelength of light that are absorbed and reflected by the planet's atmosphere, scientists can identify the chemical fingerprints of different elements and molecules. It's like having a cosmic chemistry lab.
That's some seriously impressive detective work. So these 4 planets have cloudy mornings. What happens as the day goes on?
Well, as those clouds get carried by the winds towards the hotter day side, they heat up and dissipate, leading to clearer skies in the afternoon. So imagine this. On these alien worlds, you could be waking up to overcast skies, but by midday, it's scorching hot and clear.
Wow. Okay, so 4 of the planets have this cloudy morning, clear afternoon pattern. What about the other 2?
Those are even more extreme. They didn't show much evidence of clouds, but their temperatures were even higher, especially in the afternoon. It seems like the winds are pushing a wave of scorching air around the planet, creating a sort of heat wave that follows the sun across the day side.
Wow, it sounds like a pretty intense suntan session.
Yeah.
So these hot Jupiters have some truly wild weather. But I can't help but wonder, is there any chance of finding planets with weather patterns more like what we experience here on Earth?
That's the ultimate goal, isn't it? Finding another Earth out there. And while these hot Jupiters give us a glimpse into the wild possibilities of weather in the universe,
Yeah.
they're certainly not prime real estate for life as we know it.
No, I wouldn't want to get caught in a rainstorm of molten iron.
Mm.
But you mentioned earlier that this is still a young field of study.
Right.
What are some of the challenges scientists face
Yeah.
in trying to understand exoplanet weather?
Well, for starters, we can't actually see these planets directly. We're observing them as points of light hundreds or thousands of light years away. Imagine trying to figure out the weather patterns on a baseball from miles away, just by looking at how the sunlight reflects off it.
That sounds incredibly difficult. So how do scientists even begin to make sense of the data?
It takes a lot of ingenuity and a deep understanding of physics, chemistry, and of course, meteorology. They analyze the changes in light as a planet orbits its star, looking for patterns and variations that can reveal clues about atmospheric conditions. They use sophisticated computer models to simulate different atmospheric compositions and compare those simulations to the observed data. It's like piecing together a giant cosmic puzzle with only a few scattered pieces.
It sounds like it takes a village of brilliant minds
It does.
to figure this stuff out.
Yeah,
But it's amazing what they can accomplish with the limited data we have.
it really is. But there's hope for even more detailed observations in the future. There are a number of exciting new space telescopes and missions in development that will dramatically enhance our ability to study exoplanet atmospheres.
Like what? Tell us about these new tools in our cosmic toolbox.
Well, one mission I'm particularly excited about is the European Space Agency's Exoplanet Characterization Observatory, or ECHO for short.
Echo. I like it. Sounds like it'll be echoing back some pretty cool data. What makes it so special?
ECHO is designed to study the atmospheres of a wide range of exoplanets, from hot Jupiters to smaller, rocky planets. And it'll be able to do so in much greater detail than ever before.
So we might actually be able to get a glimpse of what the weather's like on planets that are more like Earth.
Exactly. And then there's FINESS, which stands for Fast Infrared Exoplanet Spectroscopy Survey Explorer.
Okay, finesse. That's another good one. I'm sensing a trend here with these space mission names. What will finesse bring to the table?
FINESS, developed by NASA, is all about studying exoplanet atmospheres in the infrared portion of the light spectrum. This is crucial because many molecules in an atmosphere absorb and emit infrared light, leaving behind telltale fingerprints that reveal their presence and abundance.
So it's like a cosmic fingerprint scanner for alien atmospheres. I'm guessing these two missions will be working together to paint a much clearer picture of exoplanet weather.
Absolutely. Imagine the possibilities. ECHO providing detailed observations of atmospheric composition and structure, while FINESS zooms in on the specific molecules present. It's a powerful combination that will revolutionize our understanding of exoplanet climates.
And I'm guessing that understanding the climate is key to figuring out if a planet could potentially support life.
You got it. A planet's weather and climate are intimately linked to its habitability. The temperature, atmospheric pressure, the presence of liquid water, these are all factors that determine whether a planet can support life as we know it.
So by studying exoplanet weather, we're not just learning about cool atmospheric phenomena, we're potentially taking a giant leap towards answering one of humanity's biggest questions. Are we alone in the universe?
Exactly. And that brings us to perhaps the most tantalizing aspect of this research, the possibility of finding Earth-like planets with weather patterns similar to our own.
Okay, now we're talking, hot Jupiters with iron rain are cool and all.
Right.
But I'm really interested in those planets that might have a balmy breeze and a few scattered clouds. What are the chances of finding those?
Well, as we've discovered more and more exoplanets, we've realized that our solar system isn't necessarily the norm. There are countless planetary systems out there with a mind-boggling diversity of worlds.
So you're saying there's a chance?
There's definitely a chance. In fact, we've already discovered a number of exoplanets that fall into the category of super-Earths, rocky planets that are larger than Earth but smaller than Neptune.
So potentially more Earth-like in terms of composition and gravity.
Exactly. And some of these super-Earths reside in the habitable zones around their stars, where the temperatures are just right for liquid water to exist on the surface.
Okay, now I'm getting excited. Liquid water is a pretty good sign that a planet might be friendly to life. Do we know anything about the weather on these super-Earths?
It's still very early days, but the possibilities are intriguing. If these planets have atmospheres and oceans similar to ours, They could experience weather patterns driven by familiar processes like convection, evaporation, and condensation.
Ooh, so we could be talking about rain, clouds, wind, maybe even alien versions of hurricanes and thunderstorms.
Imagine that watching a weather report for a planet light years away. Today on Kepler 186, expect partly cloudy skies with a chance of methane rain showers.
That would be incredible. It sounds like we're on the verge of a whole new era of
Yeah.
exploration where we're not just finding planets, but actually getting to know them,
Right.
understanding their unique personalities, including their weather patterns.
Yeah,
It's amazing.
it is.
What are some key takeaways for our listeners to keep in mind as we continue this journey of discovery?
Well, I think the biggest takeaway for me is that we're not just searching for planets anymore.
Right.
We're searching for clues about life,
Yeah.
about other worlds that might be as vibrant and dynamic as our own.
Yeah, I think that's a great point. And studying exoplanet weather is a crucial part of that search.
Right.
It's like trying to understand a new culture.
Exactly.
You wouldn't just look at their architecture and art. You'd want to experience their daily life, their customs.
Play of weather.
Yeah, I
Yeah.
love that analogy. So if a planet's weather is like its personality,
Yeah.
we're basically trying to get to know these alien worlds on a much deeper level.
Exactly. And who knows, maybe one day we'll even be able to use our knowledge of exoplanet weather to predict which planets are most likely to be habitable.
Right.
And even target our search for extraterrestrial life.
That would be incredible.
Right.
Imagine being able to pinpoint planets that have the right conditions for life as we know it.
Yeah.
Maybe even planets with oceans, continents, and weather patterns that resemble Earth's.
It's a tantalizing thought.
It really is.
And while we're still a long way from sending astronauts to visit these distant worlds,
Sure.
the research being done today is paving the way for future generations of explorers.
It makes you wonder, doesn't it? What will those future explorers find?
Yeah.
Will they encounter planets with weather more beautiful, more dramatic,
Right.
or even more bizarre than anything we can imagine?
One can only speculate, but that's the beauty of science.
Yeah.
It's a never-ending journey of discovery. And with each new discovery, we gain a deeper appreciation for the incredible diversity and wonder of the cosmos.
Well said. And on that note, I think it's time for us to wrap up our exploration of exoplanet weather for now.
It's been a fascinating journey. Thanks for having me along for the ride.
Of course. Thank you for joining us on this cosmic adventure. And to our listeners, keep looking up, keep exploring, and never stop wondering about the mysteries of the universe.